Hello students. Today we're going to talk about dividing with fractions. I have put an entire problem on the board and then a partial problem on the next board. So when I move from one to the next, it'll be a little different look, a little different view. All right, so we're starting with this problem here, 6 divided by 1/3. And the answer is going to be equals 18. So let's see how we arrive at that answer. First of all, I drew 6 circles. Not exactly the same, but close enough. You want to, if you're drawing a picture to go with it, you want to try to make it as consistent as possible. So then I took each circle and I divided it into thirds. I have 6 things. I'm dividing it into thirds. The reason I know I'm going to divide it into thirds is because of the denominator. The denominator tells me how many parts each whole is going to have. Okay, so after I've divided each circle into thirds, now I'm going to just kind of add up how many parts that's going to give me. So there's 3, 6, 9, 12, 15, 18. All right, now you might say, but we're supposed to be dividing, we're not adding, we're not multiplying. True, but what we're trying to do is figure out how many parts we're going to end up with when we divide it in this manner. Because anytime you're dividing something, you're putting it into groups. And when I'm dividing by fractions, I want to find out how many parts that's going to give me. So what I've done is taken my 6 whole and I've divided it into thirds. And that gives me 18 parts in all. Now, there's an algorithm. We've talked about this before because this is the how we do it, and then here's the simplified version. The algorithm for this, the formula we're going to follow, the rule, so to speak. I'm going to take my 6 whole, and I'm going to multiply by the reciprocal. It's called the reciprocal. Write that down so you can see what that word looks like, reciprocal. And that just means I've inverted my fraction, turned it upside down. There is a mathematical law that allows me to do that, but for 5th grade you won't have to learn that part of it. We're going to go from the picture to using the algorithm to derive our answer. So once I keep my first digit, because that's my whole number, that's the part that I need to keep the same, I copy that first one. I'm going to change my divide to times, and I'm going to change my fraction to its reciprocal, and then I can arrive at that answer of 18. So it's copy, change, change. So my algorithm, we've talked about this word many times, that algorithm is copy, change, change. Copy the first term, change, divide to times, change the fraction to its reciprocal, or whatever the second term is. It doesn't have to be a fraction, because we're going to use this same algorithm when we're dividing with any kind of fraction anywhere in the problem. And that equals the answer, copy, change, change. Okay. This may seem a little confusing at first, and it's not even expected that you master it in 5th grade. It's an introduction to this concept, okay? So let's move on to the other board. See if I can get this one right. Okay, now this is a little bit different of a problem because I don't have 1/3, I have 2/3. Now I drew a picture where I have 6 as my whole number, but it's one solid object that I divided to show 6 parts. So here's 1, 2, 3, 4, 5, 6. Okay? Then I took each part, each number of my whole, and I divided it into thirds. Now, how did I know to divide it into thirds? Because my denominator tells me how many parts it's divided into. So here's my 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so here's my thirds. Now, what I'm going to do next is show that I'm dividing it by 2/3. So here's a 2/3. Oh, now of course I picked up a marker that doesn't work. Let's try this one. Here's a 2/3. I'll be done in a minute. Here's a 2/3. To that one. Here's a 2/3. Here's my next 2/3. Notice I'm coloring 2 of the thirds at a time. Here's a 2/3. And here's a 2/3. And here's a 2/3. And another 2/3. Notice that I'm coloring 2 sections at a time. I'm doing the 2 at a time because that's my numerator. And then I end up with one more set of 2/3. All right, now after I've colored those sections of 2/3, I'm going to see I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I end up with 9 sections of 2/3. So let me get that marker. All right, now this is the picture. Let's go to the algorithm and see if it works. So I'm going to copy, and then I'm going to change, and then I'm going to change. And when I multiply this, I get 6 times 3. Well, I could even reduce before I multiply. 6 times 3 is 18 over 2, and that reduces to 9. If I had reduced before I multiplied, I would have reduced here, and 6 and 2 times 1, let's see, that didn't work. I don't know what I was, oh, I reduced the wrong thing. See, all of us make that mistake sometimes. Okay, so 6 times 3 halves, I gotta reduce those guys. Okay, so this one's a 3, and that one's a 1. Now 3 times 3 is 9, and 1 over 1 is still gonna be 9.